Welcome to qnawire.
We have the following elemental analysis coming from the combustion of a sample of thiophene. First of all, we're going to analyze the amount of mole that is contained in 8.46 milligrams of a sample of carbon. So in order to do that, we know that 17.7 milligrams is equal to, we can transform them into grams directly, and these are grams of CO2, of course. Now what we're going to get is that in 17.7 milligrams, we're going to generate a certain amount of mole of carbon. So first of all, we're going to have 44 grams of CO2 correspond to 1 mole of CO2. And next up, 1 mole of CO2 is equal to 1 mole of carbon. So the amount of mole of carbon that is going to be on this sample of 8.46 milligrams will be equal to 4.023 times 10 to the minus 4 mole of carbon. Now we're going to find the amount of mole of sulfur that we're going to have in this sample. We know that we're going to generate barium sulfate, which has the following formula, BaSO4. And we're going to generate 14.6 milligrams of that in a 5.28 sample. So over here we're going to get 14.6 milligrams. So the procedure is going to be the same. In this case, 1 mole of barium sulfate is going to have a molecular weight of 233.38 grams per mole. So after doing these operations, we're going to get 6.256 times 10 to the minus 5 mole of sulfur in a sample of 5.28 milligrams of sample. So now what we need to do is to scale the quantity of either carbon or of sulfur to what it would be in a sample size of the same size. So for example, over here we have a sample of 8.46 milligrams. Down below we have 5.28 milligrams. So in this case, what I'm going to do is to scale the amount of sulfur that would be in a 8.46 milligram sample. We're going to do this directly by employing a rule of 3. If we know that in a 5.28 milligram sample, we're going to have 6.256 times 10 to the minus 5 mole of sulfur, then in an 8.46 milligram sample, we're going to have 1.002 times 10 to the minus 4 mole of sulfur. So over here we already have a relationship in between the amount of carbon and the amount of sulfur that we're going to get. And now the only thing that we want to know is how much of that would correspond of hydrogen. So in order to do that, what we're going to do is what is the mass corresponding to the sulfur, the mass of the carbon, and what would be the mass of the hydrogen in order to generate the total amount. Remember that the total amount of sample is going to be 8.46 milligrams. So we're going to begin with the amount of mole, in this case 1, let's round it out as 1 times 10 to the minus 4 mole of sulfur. And we know that sulfur is going to have a molar mass of 32 grams per mole. This is going to give us, additionally to that, we want the result in milligrams to be able to compare things directly and in a more simple way. What we're going to get here is that 1000 milligrams correspond to 1 gram. So the mass of sulfur is going to be, in milligrams of sulfur, 3.2 milligrams. In the case of carbon, let's round out our value to 4 times 10 to the minus 4 mole of carbon. In this case, the atomic mass is 12 grams per mole. And we are going to have the same conversion factor to get the result in milligrams directly. So 4 times 10 to the minus 4 times 12 times 1000 is 4.8 milligrams. What this means is that what we have left needs to be of hydrogen in order to get 8.46 milligrams. So this would mean that 0.46 milligrams correspond to hydrogen. And what is this in amount of mole? Well, we can do the inverse transformation. Over here we have the amount of mole. So what we're going to start with is 0.46 milligrams of hydrogen. We know that 1000 milligrams is equal to 1 gram. And we know that the atomic mass for hydrogen is 1 gram per mole. So directly 0.46 divided by 1000, which is 4.6 times 10 to the minus 4. Now here, just a comment to get a more accurate result. If we plug in here the full quantity that we had before, the 4.023, the amount of milligrams of carbon would be equal to 4.828, and the quantity of sulfur would be 3.206. So with this, we would get a mass of hydrogen of 0.426, which is a little bit more close to the actual result. Okay. So let's replace that value, because in this case, since we want to get the empirical formula, it is better to take as many decimal points as possible. So over here would be 1.002, and over here down below would be 4.023. Okay, 4.023. Let me erase the other numbers just to make it clear. (1.002) times 10 to the minus 4, and 4.023 times 10 to the minus 4. So over here we will get 4.26 times 10 to the minus 4 mole of hydrogen. So with this, we now can get our empirical formula. We're going to divide each of them by the lowest quantity, that is 1 times 10 to the minus 4, essentially. Just for second completion, the amount of mole of sulfur, carbon, and hydrogen is going to be, rounding up, 1 times 10 to the minus 4 mole, 4 times 10 to the minus 4 mole, and for hydrogen as well, 4 times 10 to the minus 4 mole. This is going to suggest directly that the formula is going to be C4H4S1. This is going to be our empirical formula. In addition to that, in this problem, we're given the value for the molecular weight, which is 84.1 grams per mole. So this is also going to be the molecular formula. Since the atomic mass matches. If you calculate the value right here, 12 times 4 plus 32 plus 4 is essentially 84. And if you take the rest of the values, 84.1 grams per mole. So with that, it would be all. Thank you very much and have a good one.